Hi, I'm Connors-Brady, and these are my final exams. Doing my math lesson first, so let's get it. Building non-successive cubes. Alrighty. Alright, I am going to be presenting this lesson today to my trusty water bottle. Thank you for joining me in Lesson Today, Water Bottle. I have noticed that you have been doing a really amazing job with your square root and cube root work. So I wanted to show you this cool material that we can use for exploring square roots and cube roots and how they equal each other and how we make the equations for them and all kinds of stuff. So let's check out this 7 cube and this 4 cube. I'm going to show you a way that this cube can equal this cube. It's pretty awesome. Look at it a little bit differently because I want you to be able to really see that cube, that piece of the puzzle. Look at that. Wasn't that cool? And then, just to make sure that I have it all the same size, I'm just going to go around and double check. Super cool. So now we want to focus on breaking these pieces apart and understanding what they mean. How did they come together to be equal in size and shape? We know this is the 7 cube. Yes. So now we want to look at all these individual pieces. Individual groupings. Now, do you see as I was building, I had my squares organized in sets, and I kept them organized in the same sets that I used to build my equivalent cube. I want to point that out because that's important, because now we're going to interpret all these to figure out exactly how these are equal. We want to make an equation. We want to be able to represent this in numbers so that we can better explain it to other people and better understand it for ourselves. So I started here with the 7 cube. So I'm going to make sure to write that. And it's important that I note this 7 cube is equal to all of these other pieces. So we're not only going to represent that with these building materials, but we're also going to represent it in an equation. So I have 7 cubed. And what do I have next? That's right, 4 cubed. And then I have 3 sets of something. I have 3 sets of 4 squared 3 times in each set. So I'm going to represent that as 3 times 4 squared, because these are my 4 squares. Uh-oh. And then what do I have here? Yes, I have 3 sets again, but this time I have 3 sets of 4 3 squared. That's right. Each of these sets has 4 of the 3 squares. And then what do I have here at the end? That's right, my 3 cubed. So I'm able to come up with this awesome equation that takes what we were able to build and turn it into numbers so that we can exactly better understand it and better explain it to others. If we were to work all this out, would all of this equal 7 cubed? 7 times 7 times 7. Absolutely it would. Isn't that so cool? And the cool thing is, we can do that same type of thing with all of the cubes in this box. Figure out ways to make equivalent cubes through non-successive cubes. Pretty awesome. Do you have any questions for me? Well, thanks for joining me in lesson today. So that was it. That was an awesome draw. So for the questions, what are the prerequisites for this lesson? The prereqs I would have for this lesson are any work that the children are doing with cubes and squares. So whether it be the chains, the square root board, the squares, anything that would build them to this skill so that they're already understanding the basic concepts of what squares and cubes are. So while it doesn't, to me, have to be any specific material, it's just understanding those foundational concepts is what I would be looking for. What would you do if the student did not seem to understand the lesson? We would take it back to those other materials and start looking at things in a more concrete way. The chains comes to mind because it provides that awesome way of building the squares and then building the cubes so the children are able to physically see what they're doing and what those numbers mean. So if they were struggling with these more advanced algebraic concepts, more abstract thinking, we would just take it back to those more concrete measures. What are your points of interest for this lesson? Oh my God, so easy. They finally get to build. Are you kidding? That's what every kid wants to do, is just play with the materials. And this is the closest they will probably ever come to just building and playing with the materials. Because when they, for me, understanding how to put them together was easy, but the kids won't. So they'll be able to have fun trying to figure out how the pieces fit together and what sizes they need to be able to make them equivalent. So I know for a ton of my kids, and not just the boys, they will love that. The hands-on aspect of building and figuring it out, they'll just be freaking out for it. The control of error, I would say, is the size of the cubes. You want that equivalency factor. So they know that until they have the large cube and the building of the smaller cube equivalent, then they haven't done it correctly. So that size factor really helps with the control of error. And what would the students do after this lesson is over? I would have them do more of this work. I would just have them do this work with other numbers and different size cubes and try to figure out all the different ways to build equivalencies. So as I restore, that's the last question. All right, that's it for my math final exam. I hope I blew that out of the water for you, Mary.